In our last set of lessons, we looked at exponential functions and graphs, and I did a video on reviewing exponents and how exponents work. And I asked you at that point to try to do as much of the math in your head as you could, or manually, rather than using your calculator. Because the lesson we're going to start today, logarithms, we're going to see that logarithms are exponents backwards. In other words, if we have a function, y equals some number a to the x power, and that a, remember, was a positive number and not equal to 1, we saw that if we graph that, we had a graph that looked something like that, depending upon how large or small the number a was. And we can see from this that this is a one-to-one function because it passes the vertical and the horizontal line test. For a review of one-to-one functions, look back at our lesson on inverse functions that we did earlier in the semester. So we can see that this function, y equals a to the x, must have an inverse because it is a one-to-one function. And remember how we find an inverse function is we switch the x and the y. So this y is the result if we take some number to a power, and this y is the exponent to which we would take a to get x. And we can rewrite this statement as a logarithm. So we would say the logarithm base a of x is equal to y. Logarithm base a of x equals y. In other words, what power, what exponent of x would equal y? And I know using all these symbols, it's difficult for you to understand what I'm saying. So let's go ahead and look at some examples. I think all of you are very aware that nine is equal to 3 squared. This is an exponential statement saying 3, my base, to the power of 2 is equal to 9. I can write that as a logarithmic statement saying the logarithm, my base here is 3, logarithm base 3 of 9 is equal to 2. So I'm saying 3 to what power equals 9? Let's look at another one. Suppose I say 32 is equal to 2 to the 5th power. I want you to pause the video for a second and rewrite that as a logarithm. All right, so what we said is that this statement is equivalent to saying that the logarithm, and my base here is 2, of 32 is equal to 5. Let's look at this another way. Let's say that I said logarithm base 2 of 16. And we want to evaluate that. What we did on the last two examples is we just rewrote a statement, a true statement, in a different form. What we're doing here is we're actually evaluating and finding what power, what exponent on 2 equals 16. And you can just repeatedly multiply 2 times itself until you get to 16 and see how many times you multiplied. Go ahead and do that and write your answer. And we see that 2 to the 4th power, 2 times 2 times 2 times 2, 4 times, is equal to 16. So the logarithm base 2 of 16 is equal to 4. So the logarithm, the whole logarithm, is the exponent. Logarithms are exponents. Let's try a couple more here. I'm going to write several down. And then I want you to work them yourselves. And then we'll come back and see what our answer is. And a couple of these you might need to remember your exponent rules about negative exponents and fractional exponents, how those work. So go ahead and pause the video and see if you can evaluate these 3 logarithms. Okay, so on this first one, what we're thinking is 3 to what power equals 27? 3 times 3 is 9, times 3 is 27, so 3 cubed equals 27. So my answer here is 3. On this one, we're thinking 5 to what power equals 1/5? Now we see this 1 over 5. That should immediately make me think, oh yes, this is a negative exponent. 5 to the negative 1st power equals 1/5. So this one is -1. And then on this one, I'm saying 16, because 16 is my base, to what power equals 4? And if I remember, the square root of 16 equals 4, and that I can rewrite the square root as a fractional exponent, I see that 16 to the 1/2 power equals 4. So this one is equal to 1/2. Let's do a couple more of these. I'm going to write several more, and I want you to try to work them yourself without using your calculator. And then we'll look at them. So let's say we have the logarithm base 10 of 10,000. Evaluate what that's equal to. The logarithm base 3 of 1 over 81. And then the logarithm base 5 of the cube root of 5. So in each case, you're thinking the base to what power equals the argument. This number here is called the argument. And that exponent is the logarithm. So pause the video for a minute and work on those 3. All right, so on this one, we're saying 10 to what power equals 10,000? Well, every time, it works out with 10, base 10, every time you multiply by 10, gives you another 0. So on this one, 10 to the 4th power equals 10,000, so this one is equal to 4. We're going to see in our next video that the logarithm base 10 is a special logarithm and it has a special name, but we'll explore that more in the next video. on common and natural logarithms. Then if we have logarithm base 3 of 1 over 81, we're saying 3 to what power equals 1 over 81? Well, I know 3 to the 4th power equals 81, but I have 1 over 81. So that tells me 3 to the negative 4 power equals 1 over 81. So this one is equal to negative 4. And then on this last one, if I rewrite this, if I rewrite my argument, the cube root of 5 is 5 to the 1/3 power. So this is literally saying 5 to what power equals 5 to the 1/3 power. So it's just going to be 1/3. All right, so that's an understanding of how we can convert any logarithm to an exponential statement instead. And I've been working with logarithms for a long time, and I will tell you that every time I look at a logarithm, I have to convert it to an exponent to be able to solve it, to evaluate it. In our next lesson, we're going to look at some special logarithms, base 10 and base e. So that video will be the common and natural logarithms.